Have you ever stopped and wondered, what is the world really like when you're not looking at it? I know it sounds like a philosophical riddle, right? But it's actually one of the biggest questions in modern physics. Today, we're diving into a single experiment that so completely shatters our everyday sense of reality, it forces us to question what it even means for something to exist.
Look, you don't have to take my word for it. The brilliant physicist Richard Feynman said it best. He wasn't talking about some super complex thing like black holes or string theory. Nope. He was talking about something way simpler but infinitely weirder. An experiment that he claimed holds the only true mystery of the quantum world. And trust me, once you wrap your head around it, it'll change how you see, well, everything.
So what is this big mystery? Well, it all boils down to this fundamental contradiction, a kind of split personality at the very core of existence. Everything in the universe, from a beam of light to the electrons inside your own body, seems to be living a double life. So, on the one hand, you've got particles. Just picture them as tiny little paintballs. They're in one specific spot, they travel in a straight line. Pretty simple, right? But on the other hand, you've got waves. Think of ripples spreading out in a pond. A wave isn't in just one spot. It's this spread out thing that could be in many places at once. Particles and waves are like total opposites. Something can't be both, can it? Well, this is where quantum mechanics just goes, hold on a second.
To solve this puzzle, scientists came up with one of the most brilliant and famous experiments in history. It's called the double slit experiment. And the way it's set up is just deceptively simple.
Okay, here's how it works. You have a little cannon that shoots out electrons. But get this, it shoots them out one by one. These electrons fly towards a wall that has two little parallel slits cut into it. And behind that wall, there's a detector screen, kind of like a movie screen, that just makes a little mark wherever an electron hits. That's it. Super simple. And it's all designed to answer one question. Is an electron a particle, or is it a wave?
And you know, this isn't some new puzzle. This whole thing started way back in 1801 with light. But the real shocker came in 1927, when scientists found that electrons, things we were sure were solid little particles, did the exact same weird thing. And then, in 1989, an incredible experiment actually filmed the results building up, one single electron at a time, proving once and for all just how bizarre this all is.
So, what did they find? All right, this is the part where you just have to leave your common sense at the door. Seriously. The results of this simple experiment are so bonkers they defy any kind of normal explanation. Let's just think about this for a second. If an electron is a tiny paintball, it's got to go through either the left slit or the right slit, right? So after you fire thousands of them, one at a time, you should see two straight lines on the screen behind the slits. A clear, simple, particle-like pattern. Makes sense. But that is not what happens. Not even close. Instead, what shows up on the screen is a pattern of many stripes, bright ones, dark ones, bright ones, dark ones. This is called an interference pattern, and it's the undeniable signature of a wave. It's what happens when waves overlap and either cancel each other out or build each other up. The only way to get this pattern is if each electron somehow went through both slits at the same time and interfered with itself. And remember, we're firing them one by one. How is that possible?
So this is where it gets even crazier. Physicists were completely stumped, so they decided to try and outsmart the electron. They put a tiny little detector right next to the slits to actually watch and see which path each electron took. And the moment they did that, the weirdness just stopped. The interference pattern completely vanished. And the electrons went right back to acting like good little paintballs, making just two simple bands on the screen.
I mean, let that sink in. The simple act of measuring which slit the electron goes through forces it to stop being a wave and act like a particle. If you don't look, it's a wave. If you do look, it's a particle. It's almost as if reality itself changes based on whether or not we're observing it. And just to be super clear, observing here doesn't mean a person with eyeballs has to be watching. Any measuring device that gets information about the path has the exact same effect.
So, what on earth does this all mean? How can reality be so slippery? This one experiment has led to some of the most mind-bending ideas about the nature of the universe. Let's check out the two most famous interpretations. Okay, so the most common explanation is called the Copenhagen interpretation. It basically says that before we measure it, the electron doesn't really have a definite position. It exists as this fuzzy cloud of all possibilities at once, a state they call superposition. This cloud is a wave of pure potential.
Then the act of measuring it forces this wave of possibilities to instantly collapse and pick one single spot to be real. So in this view, observation doesn't just see reality, it actually helps create it. But then, there's an even wilder idea, the many worlds interpretation. This one says the wave of possibilities never collapses. Instead, every single time a measurement like this could happen, the entire universe splits. Every possible outcome becomes real, but in its own separate parallel universe. So in one universe, the electron went left. In another, it went right. And you split right along with it. There's another you, right now, in another reality, who saw the other result.
I mean, both of these ideas are just staggering. One says we create reality out of a fog of probability just by looking. The other says we're creating an infinite number of parallel universes every single moment. And all of this brings us to the final, really unsettling question at the heart of it all.
If this simple act of measuring something fundamentally changes what happens, then what is the universe truly like when we're not there to observe it? Is it all just an undefined sea of potential, waiting for a conscious look to snap it into reality? Or is it this endlessly branching tree of parallel worlds? The double-slit experiment doesn't give us the answer. It just shows us, in the clearest way possible, that the solid, predictable reality we think we know might just be one tiny piece of a much, much stranger truth.